If we want to show multiplication on a number line, let's go back to some whole number ones. So if I had 2 times 4, you can see that I've already drawn 0 to 2, and so we can work out on the number line how long 2 is. And so our multiplication is saying we need 4 lots of that length. So we're going to mark those in now in hops along the number line. So there's 1, 2, 3, 4. So 4 lots of 2 equals 8. Not really a very surprising answer. If I want to find a written method to find the solution to this, what I need to do is, as we've talked about before, we need to change these two fractions into improper fractions. So looking at the first one, we've got 2 holes there, and in each one of those holes there are going to be 4 quarters. So that means 2 lots of 4 and then another 3 quarters up there, so that makes 11 quarters altogether. Similarly, if I do the next one, I've got 3 holes and I've got ninths. So each one of those holes has got 9, so 3 nines are 27, and another 7 makes 34 ninths. Now I can go straight across and multiply those, but as we've been talking about, we can simplify that fraction. We can think of equivalent fractions, and I can see that there's a factor of 2 in the numerator, so factor of 2 of 34, and in the denominator a factor of 2. And so as we're looking at in the lecture, we can think of that as 2 divided by 2, which is 1. And so that leaves us with 11, and dividing that by 2 to remove that factor there, we've got 17 left behind. And on the bottom, I'm going to use the 1 vinculum because they're all multiplication and division. We had this 2 as a factor of the 4 here, and so that leaves us with 2 and then 9. So across the top there, I can see that multiplying by 11, you write down 1 and 7 and add the 2 together in the 8, and there's an interesting little mathematical problem for you to work out why that works. It's rather fun to look at. So I've got 187 over 18, but I can make that smaller. I can reduce that down, and I can think of, well, I've got 10 holes because 10 lots of 18 is 180, and that'll leave 7/18 behind afterwards. So just moving this up. Oh, that's interesting. Maybe I won't. I'll put it over. I'll put it down here. So equals 10 and 7/18. So let's have a look at this on the number line on the next slide. Okay, well, when we want to show multiplication of fractions on a number line, it's quite necessary to have a number line accurately drawn, because little discrepancies in the measurements can make a big difference when we're looking at these fractional quantities. So what I've done is taken these bits here and I've copied them, and these are all the same length, and they are measured to be 2 3/4. So what we want to do is multiply these lengths just like we did with 2 times 4. Well, here we've got these lengths of 2 3/4, and we want to multiply them by 3 and almost 4. So we're going to, I've got 4 of them here. Well, it'll be, our answer will be between 3 of them and 4 of them, and closer to the 4. Now let's see how we go. So now I'm going to move one of these pieces and I'm going to line them up. So I've got 1, 2, 3. So my answer is going to be So my answer is going to be more than 8, and we need to take another one, but it's not going to be quite 4, remember, because as we see here it's only 3 and 7/9, so our answer is going to be less than 12, so it's going to be probably around about, we'd be thinking somewhere around about here, and that's as close as I think we can get. We could certainly do it by careful measurement and exact joining up. So it is possible, and the ancient Romans would have done it like this with measuring lengths, but what we want to do here is just get an approximate answer and to have an understanding that what we're doing along our number line is really just saying hop, 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 and getting a sense of where our answer is likely to be. The written method or use of a calculator is probably going to be necessary to get an exact answer. It certainly is for me.